question that affects perhaps how fast plates move, and certainly affects our ability to think about what the plate tectonics in the past may have looked like, is the age of the plates. That is, what is the age distribution? There's going to be young ocean near the ridges and older ocean as you move further away. Is there a systematic pattern to that? So students can use the magnetic anomalies and the outline of the plates to determine this age distribution in the plates.
Right. And so with the globe, we have this information about how old each of the magnetic anomalies are. And so you can simply correlate with color and the symbol shape exactly how old that anomaly was when it formed. And so we can go to our globe here and say, okay, well, we've labeled anomaly 5N.2N, so we could just simply draw here. This is an age line, and we know everything to the west of this is younger, and everything to the east of this is older. We could similarly divide along another set of anomalies. So here is 8N.1N, and we could divide there as well, and divide our plate up. And once we've done that, we can take our area measurements and simply count up how much of the plate is younger than this age, how much of the plate is between these two ages, and how much of the plate is older.
And this is the type of information that people use to try to think about questions like, how would sea level be different if you had faster or slower spreading? What was sea level like in the past if you had different age distributions of the ocean floor? And so students can actually do these calculations, find out what present day age area distributions are, and then think, how would that be different if ridges spread faster or slower in the past?